Hi everyone, in this video we will talk on SSR solid state relay, and we know that these materials are being used in industrial area frequently, and today we will talk on these materials, and we are going to try to understand the difference between SSR and relay and contactor. We can say that there are many similarities between SSR and relay and contactor. Both of them are trying to make switching, and we can say that the aim of these materials are the same, to make switch. But there are many differences. A solid state relay is a relay that does not have a moving contact. Also, relay and contactor has a moving contact, moving parts, but in the SSR there is no moving parts, moving contacts. In terms of operation, SSRs are not very different from mechanical relays that have moving contacts. SSRs, however, employ semiconductor switching elements such as thyristors, triacs, diodes, and transistors. And these parts, unlike the relay and contactor, these parts is electronic parts and working with electronical principles, and relay and contactors working with mechanical and electromagnetic principles. On the screen we see two parts, two sections. One section is mechanical relay, another is SSRs, specifications of SSRs, and we will explain with a picture and with the symbolic pictures. As we see above, you know that there is a coin here which belongs to a relay or a contactor, and as we see, when we activate this coin, this section will be activated and will change the position of its contacts, and will make switching like this, as we see. So when we activate this coin, we know that these parts, this switch, these contacts will be changed. Normally open will be normally closed, and normally closed will be open contact. So this process is switching process. Also, the conditions are the same for the SSR, solid state relays. We can see that there are two parts on an SSRs. This section is input, this section is output section. When we activate this area, like the coin, this guy will contact and will pass the power from one contact to another, and this section will be activated when we activate the input. So we can say that the principle is the same with the relay, and in relay we activate a coin, and in SSR we activate the electronic parts. So the output is the same. The aim of to make a switching. In a relay, we make switching with the moving parts, with the electromagnetic principles, and in this SSR we make switchings via electronics methods. Also, in this picture we can see that there are two parts in SSR's input section and output section. We see that when we activate this section will send a light to output area, and a device in output area will activate with the lights coming from input, and with this way this guy will change its switch and send power to output like this. For example, we can say that there is a switch here. When this guy is activated, it will send light to this guy, and this guy will switch its output, and the power, for example 22 volts, will come out, and we can say that we can 24 to load. Also, in this concept we can say that between input and output there is a isolation, and in the output section the voltage in output section will not affect the input section. You know that there is no physical or any magnetic parts connection. There is a isolation. Just this guy sent lights, and this guy is activated. With this way, this SSR can make their aim, can make their work. Also, we can say that for the relay, for the contactor, there are two parts and separated each other. You know that we send 24, for example 24 DC volt to this coin, and with this way we can pass 22 voltage in the contact. So we can say that with this way there's also isolation also here. Power section, physically power section and control section are separated each with the other. You know that in the industrial area there are two main types of SSRs. The contact of the SSR maybe 1 or 3 contact, monophase and triphase SSRs. In the industrial area we can see these types of SSRs. The principles is the same. This is when we activate this area. Also in this section, this area, this guy will send 3 parts of the power: A phase, B phase, C phase. When we activate this area with 3 or 22 volt DC, in this example, when we activate with this voltage, this guy will pass this voltage from input to output, from the source to load. Also in this part, when we activate the input area with related voltage, the power will come here to here and will pass on this section when we compare with the relays, there are many advantages of SSRs, and now let's talk about them. SSRs provide high speed and high frequency switching operations. You know that this parts belongs to a relay switching systems, and we can take a high speed with the relays, so it may be a problem for the moving parts. So if we need more speed, more high frequency switching operations, we can use SSR, and SSR can make more these issues, more frequency switchings easily. Another advantage of the SSRs is no moving mechanical parts. You know that in the conductor, in the relays, there are mechanical parts, and this may be a problem. So in the SSRs, there are no moving parts like this. So the life of the SSRs is higher than a relay, we can say. Also, another advantage of SSRs is we can use SSRs in the explosive and harsh environments. You know that mechanical with the when we activate a relay conductor, this guy will change mechanically their contacts, and maybe in higher currents there may be problems. There may be spark, there may be arc with in the relay contacts. So this issue is very dangerous for the explosion area. So if we want to use a switching material, we need to use SSRs in this environment. Also, another advantage of the SSRs is this guy don't generate electromagnetic interface and are also smaller in size. So you know that in the as we mentioned before, relay paths in the conductor, in the relay, there are many moving parts, and when this guy when this part is activated, the position of the contact will change. Also, the coin will be under energy, and so with this way, during this process, icon with during this process, relays and its their contacts can generate an electromagnetic interface, and this interfaces, this electromagnetic problems, can disrupt the process. But in the SSR, there are no electromagnetic interface, and there are no problems like this. Also, SSRs has a lower power consumption. Also, they have long life because they don't have any physical wear or contacts. Also, they don't make noise when they work. They can switch higher current loads also. and they doesn't generate sparks during its operation. As a result, can say that mechanical relays have contacts and use electromagnetic force to mechanically open and close the contacts to turn on off signals, currents or voltages. SSRs don't have the mechanical moving parts that mechanical relays with contacts do. Instead, they consist of semiconductors and electronic parts. SSRs turn on off signals, currents, or voltages electronically by the operation of these electronic circuits. So the principle, the last principle, the final principle is the same, but there are two main differences. In the mechanical relays there are moving parts, but in the SSRs there are no parts like this. I think it is enough to understand the difference between SSRs and relay or contactor. Thank you for watching. If you like this video, please subscribe and advise your friends. See you next video.